Hello, ladies and gentlemen. I'm Joe Rapari, and this is Tab, the Truth Always Boomer. Well, I wanted to take this ventilator situation and put it into perspective. So let's pull the tab on that and see what happens. So let's talk ventilators. You know, medical ventilators. Excuse me. And I'm going to use my 35 years of manufacturing engineering experience and try to put this in perspective for you. There's been a lot of talk about, where are all the ventilators? Why don't we have ventilators? What's going on with the ventilators? We need ventilators. Let's make some ventilators. Sure, we can make ventilators. But let's all take a deep breath and relax. And let's see what's going on, okay? You know, there's a lot of things going on with these ventilators. So let's take a look at that, shall we? So let's check this out. Ford works with 3M, GE, UAW to speed production of respirators for healthcare workers, ventilators for coronavirus patients. Dearborn, Michigan, March 24th, 2020. Ford Motor Company joining forces with firms including 3E and GE Healthcare is lending its manufacturing and engineering expertise to quickly expand production of urgently needed medical equipment and supplies for healthcare workers, first responders, and patients fighting the coronavirus. That's all well and good, but let's take a step back and look at this logically, shall we? Hamilton Medical is the largest medical ventilator manufacturer in the world, and this is the kind of ventilators that they produce right here. And here's a picture of their plant. Now you can imagine what that plant is like. There's 350 people working at that plant, and they're already working 3 shifts, 8 hours a day, or 8 hours a shift. So you know they're working 24/7 to churn out these ventilators. But there's absolutely, positively, absolutely no way that Ford is going to be able to make ventilators like that. Now supposedly GE Medical has got some toned down version or some kind of a smaller unit that they can use. Well, I sure hope that's the case, because I'm going to show you some things here and show you just how hard it is to make a ventilator, or what it takes to make these kind of things. I'm not trying to be a naysayer or doom and gloom. It's great we're all doing this, but I want to put all this in perspective. It can be done. Of course it can be done, and it can be done quickly, but it does take a little bit of time. And so let me get into this with you a little bit more, okay? Now here's a toned down version of the ventilator, and this was designed and built by MIT researchers, and it's a simplified version. But even though it's simplified, it's still kind of complicated. And this is something that Ford, working with GE, probably could do. But there's no way they're going to build those ventilators that Hamilton Medical builds. There's no way. They can forget that, right? They can forget that noise right now. Here's another look at it. And here's it in an actual hospital setting being tested. So I'm going to go through this and show you exactly, even with this simplified version, what it would take to make this thing. It can be done. It's not impossible. Of course not. It can be done. And you know, it could be done relatively quickly and quite well, but they got to get off their asses and start doing something, man. I'm going to show you what it takes. And so let's look at that now, shall we? Okay, so let's say they came up with something like this, and it works. We don't even know if it works, but let's say it works. And we came up with something that looks similar to this, and we want to make 20,000 of them, an initial run of 20,000, which would give each state 400. And so you got 20,000 of these. So look at this piece right here. All it is a piece of plexiglass, and it looks like it's been machined or cut out. So let's say you could do 10 of these at a time. So that would be 20,000 divided by 10 is 2,000. And it takes about 30 minutes to do it by the time you set it up and do it and machine it, or however they're doing it, cutting it out, or however they're doing it. So you got 2,000 times 30 minutes is 60,000 minutes. 60,000 divided by 60, which is the number of minutes in an hour, is 1,000 hours. 1,000 divided by 24, the number of hours in a day, is 41.6 or 42 days. Just to make this one part. It would take 41 days if you had, okay, so if you wanted, you got to get a whole bunch of manufacturers going just to make this one part. If you want to cut this down to a reasonable amount of time, like a week or so, or 2 weeks or whatever. So just this one part would take 41 days to make enough for just 20,000 of them. So let's keep going. Okay, so now let's look at these aluminum extruded parts right here. They're about 18 inches long, so you got 18 times 4, because there's 4 of them here. There's 2 on this side, 2 on this side. That's 72. So 72 times 20,000 is 1,440,000. And you take that 1,440,000 divided by 12. That's how many inches are in a foot. You get 120,000 feet. And 120,000 divided by 300 feet, which is the number of feet in a football field, you get 400. So you need 400 football fields of this stuff. That's how long, if it was one piece, it would have to be 400 football fields long. Now, I don't know which manufacturer has enough of this stuff in stock. There wouldn't be one. You'd have to go to multiple manufacturers. Is anybody doing that right now? Nope. Is anybody looking into how much this stuff costs, where you can get it, who's got how much of it? No. They're just all, I don't know what they're doing. They're all pulling their dicks, man. I need to get in there and take charge of this shit, man. They don't know what they're doing. Come on. I'm not saying if this can be done, but man, they're not doing anything right now. I guarantee you nobody's looking into who's got 400 football fields of this extruded aluminum to put into this assembly. Guaranteed. And what about these little pads that squeeze the bag so the air can come out and go through the tubes and get into your lungs? So you need 40,000 of those because, you're making 20,000 of these little units here. So you got 2 of them. That's 40,000. What does it take? 30 minutes to make one of these little pads? So that's 40,000 times 30. That's 1,200,000 minutes. Divided by 60. That's how many minutes are in an hour. That's 20,000 hours. So you got 20,000 divided by 24. That's 833 days. Jeez. So let's say you had 20 machines doing that. You could get that down to 42 days. Who's got 20 machines? What 20 machines are now either 3D printing or machining these or whatever, however they're making them? There's a number of ways you can make this. And so who's doing that? You could plastic, injection mold them, whatever you're doing. Who's got 20 machines dedicated to these 2 little pads? Nobody's doing that now. I'm not being negative. I'm just saying, let's get going on this, man. We need to be getting these suppliers. Even if Ford does it, Ford's not going to make these parts themselves. Any of this shit. They're not going to do that. They're going to just assemble the damn thing. Ford doesn't make the parts for the cars. They import all that stuff from around the country and overseas. Then they just assemble the cars. That's what they do. They've outsourced all the other stuff. They assemble cars, just like they'll be assembling this. They might have a few manufacturing facilities that can machine and 3D print and do all that stuff, but certainly not enough to make 20,000 of these damn things. So they're going to have to outsource this to other suppliers who are expert at doing all this machining and 3D printing and stuff so they can get it done really quick, and then they can put it all together. So let's keep going. Now check this out. This is a real simple one. Everybody's saying, "Oh, where are all the ventilators? Why can't we get ventilators? Let's just go get them. Let's snap our fingers, or let's go to Walmart and pick them up, or go to Myers and pick up a ventilator." Check this out. Look at these screws here. 1, 2, 3, 4. So there's 8 of them. You need 8. So 20,000 times 8 is 160,000. So they probably come in boxes of 30. So you got 160,000 divided by 30 is 5,333 boxes of just these screws. These little bitty screws. You need over 5,000 boxes of these screws. 5,000 boxes. People don't realize. And this is just a simple version of this. You've got these main manufacturers like Hamilton churning out the real complicated ventilators, but they can only make them so fast. They're the experts. They're doing that. Don't even think about trying to do what they're doing. You need to set up a whole nother plant for this. At least Ford or GM or Chrysler can get a spot in one of their plants they're not using or whatever and set up an assembly line to build this little unit here. They got a chance with this, but nobody's doing that. Nobody's looking into that. They got all these people on the task force. Let's do something, man. I guarantee you, these guys at MIT, they don't know anything about where to outsource all this stuff. They're not manufacturing engineers. They don't know anything about that stuff. They know, this is a nice little school project that they did here, So now let's get into the real world and let's get this done. They need guys like me with years and years of experience who know how to get this stuff built, know how to get this stuff machined, get it made, and how to design an assembly line, and how to, are we going to use some robots? Are we going to use people? What are we going to do? We got to get this moving right now. It can be done. It can be done. They need the right people, Mr. President. I'm the right guy for this job. I volunteer. Jeez, oh man. See now, people? That's why there's no ventilator. These things are complicated. Even this little simple one. It's pretty complicated. It takes a while to do all this stuff. You need the right people to get this stuff done. It can be done. It's not impossible. It's not even anywhere near impossible. It can be done. It's very, very feasible. But you look at the logistics here. This stuff takes time, and you need to make this stuff, by the thousands, man. And then you want to churn these out and get them to the places that need them. Let's continue. And last but not least, here's the unit in a real-world application, or this is what it would be in the field. The patient would be over here on a table or whatever, and there would be tubes coming out of here, and then they would, set it up onto the patient so it would breathe for the patient as these paddles squeeze this little bag in and out. So yeah, look at this. And so you need 20,000. Just the initial run of this would be 20,000. You need 20,000 of these computer screens. Oh, look, you need 20,000 of these little black boxes with all the electronics inside of it. 1, 2, 3, 4. 4 times 20, 20, 40, 60, 80. You need 80,000 of these little buttons to put on, and then you need 20,000 of these little ducts, to put on top of the black box. And it's important to have this duct there too, And then, all the wires and tubes and everything you need for this stuff. These things, even though it's simplified, it's still, so what are you going to, you got to get an assembly line. You're going to have people. Yeah, you're probably going to wind up having a manual assembly line. There ain't no robot going to put this together, And then here's another little simple thing. You need a program to make this thing work, to go in and out at a certain time and breathe for the patient. I'm sure that program's in here. It's probably written, and it goes into the computer and makes this thing go. The electrical engineers did all that stuff. But, how long will it take to download 20,000 programs into computers? Just that little step alone is going to take time. They need to get going on this stuff. It can be done. Let's move it. If this thing works, let's go. I'd start building a bunch of these right now. It looks like it's going to work. It looks pretty feasible to me. Hopefully it'll work. But this is what they're going to have to mass produce. It's going to have to be something like this. You can forget about those sophisticated ones at Hamilton Medical. They'll forget those. They got 350 people working at an assembly plant dedicated just to making those sophisticated things. They got that down pat, man. They, lean manufacturing and all that stuff, Kanban and all that good stuff, man. They got all that down pat. They know how to make them, and they can only churn out so many of those. But these, you got a chance with these. I'm not trying to be negative. I'm just saying it can be done, but we got to get our asses moving. So let's go. They need guys like me in there who know what the hell they're doing. How to gather up all the vendors and suppliers and everybody that can build and assemble all this stuff. Ford's got plants they're not using. They could set up an assembly line in one of their plants. But man, that's going to take time. They got to get this stuff moving. So just wanted to put some perspective in that for you, ladies and gentlemen. This stuff, it's complicated, man. Everybody thinks, well, why do we have any ventilators? Well, this is why. These things take time. Nobody thought we'd need so many ventilators. And now that we do, we can't just build them overnight. It takes time, man. You don't just snap your fingers like I Dream of Jeanie and Bewitched. This stuff is in the real world, man. You need to manufacture this stuff. You need to machine it. You need to build it. You need to plastic injection mold it. You need to 3D print it. You need to put it on a CNC machine. You need to extrude it. You need to machine it. You need machine tools. You need machines. You need electronics. You need plastic. This stuff all takes time, and you need somebody who can coordinate it all. Mr. President, I volunteer my services. So that's it for this video. If you like it, give it a thumbs up, subscribe, hit the notification bell. More news later. Take care, and as always, be safe. And remember, Mr. President, I'll volunteer my services. I can get this done for you. Take care, everybody.